Um, welcome. Oh, I have the sound turned on here. I'm watching my stream on my tablet so that I can see the chat without having to, do it here. So it's a bit easier for you, you know. Anyway, um, and yeah, I'm wearing the Whitehat merch. I don't know if you guys can see it or not, but you can order it already. It's awesome. It did take a little bit to arrive, but looks pretty nice, if you ask me. Wait, yeah, you can see it. Fair enough. Anyway, um, and by the way, for some reason, if you go into the website, so whitehathacking.tech, um, there is supposed to be a merch icon here. I'm not sure why this has disappeared or if I just forgot to add it. But you can get the merch by going to whitehathacking.tech/merch. Merch. And it's going to take you to the merch. Right now, only these three items are available because of the situation right now, but there are many more that are already designed and will be ready to go as soon as the store um, can handle it. Anyway, hello guys, hello Arkska. I never know how to pronounce your name correctly. Okay, let's go into today's topic. So let's just go into what we've done already. I already added the modules and exercises for not only last week's, well, not last week's, but the previous video, but also for today's content. And it should be here in Python Basics. We can see another functions topic, which we had covered before, and today's topic, which will be loops. Maybe just one or two more things, depending on if people have any questions or something. Um, so let's go into the exercise for the functions. In case you haven't done this yet, I'll do this in the end because some people haven't read it yet, I guess, or I don't know. I'll just do it in the end so that people can access it if they want to or not. In any case, the current topic is loops. So in the previous lesson, we learned about functions, how to create functions and whatnot. And in this one, we're going to be able to work with loops. So we're going to be looking at, so the whole document is here if you want to follow it as well. I'm going to follow it slightly. I wrote it today, so maybe there might be some typing errors. I haven't actually reread it yet. Hey there. Um, so let's just get this started with. There are two main types of loops, while loops and for loops. Now, loops are basically constructs that allow you to repeat a specific set of instructions more than once, right? So let's say you have, let's take this loop for example, right? I'm just going to copy paste it here. The basic construct for a while loop, which we're going to be talking about first. So let's just write a little comment. I hope this is big enough for you. Is very similar to the if construct. So you have a statement, so the while statement, and then you have a condition followed by a colon, and then whatever is inside of this loop in terms of code. Do you mind adjusting your mic? Sure. Is the mic too loud, too quiet? How is it? I'm sorry, the delay here is not amazing, so I might be reading things in a bit later than what you're typing. Let's put this a bit smaller so you guys don't have the whole volume is okay in my opinion. Okay. I can make it louder, but I don't want it to distort or to clip, which is why I did it like that. But I removed the pop filter because it was the pop filter in the way that I have it right now needed to be at a particular distance so that the microphone would actually be farther away. Now the microphone is a bit closer. Okay, fine. Okay, that's awesome. Okay, so back to the construct. So while loops are constructed in a similar way to if statements. So you have while, then you have a condition. We have a colon, and then everything inside of this indentation level is going to be part of the while loop. And what this will do is it will basically check for this condition, and if the condition is met, everything inside of it will execute. And then it will check for the condition again, and if it's still met, everything will execute. So this will execute until the condition is not true anymore. So as long as the condition is true, it executes. So for example, this, the condition is 1 plus 1 equals 2, and this is true, so this will execute. Now there is 1 plus 1 will always be equal to 2, which means this loop will run forever. It's an infinite loop. Now instead of opening up PowerShell to run this, I thought it would be better to just use the inbuilt code running of VS Code. Now you can, I actually have an extension for that. It's called, let me put this down a bit. It's called Code Runner. You can just install it here. Code Runner right here. And the only setting you need to add is here in your settings. So this right here. Although you don't need to type all of this, okay? The only thing that you actually need is this, is for Python. Well, in any language you want to run with this. Where's Python here? I don't know. Here. So this is the only thing you actually need. So if you start typing it, code runner executor map. So if you click enter on here, the whole thing will be generated. And then you just go into your Python and you change this to Python path and you full file name. I believe this was it. And then we can run this. Oops, what did I do wrong? Oh, sorry, $sign, my bad. So now if we run this, you'll notice that this is actually executing forever. It's always printing this because there's no condition to stop, right? So let's stop this. And when we stop this, this loop is it stopped? Stop code run. Stop code run? Code run doesn't like infinite loops, huh? Wait, is it stopped already? I don't really work with Code Runner all that much, so well, let's oh no, it's still running. Okay, this is not working, I guess. Well, I should not have tried to run an infinite loop in here. My bad. Well, let's try reloading. I'm not sure if this reloads as well, but it should. Ah, sure. Not. Yeah, okay, it reloads too. This is great. Okay, so as we said before, that goes into an infinite loop, right? Because 1 plus 1 is always equal to 2, and then whatever executes in here will execute forever. But what if we have a variable, say I equals 0? Now, while I is less than 10, for example, we're going to print I. Now, this will also run forever because it will first check if I is less than 10, and it is because it's 0, and it's going to print I. And then it's going to check again. And I is always 0, so it's always less than 10. But inside of the loop, we can change this by saying I equals plus equals 1, which is the same thing as saying I equals I plus 1. I think I covered this before, but if I didn't, that's the same thing. Now, I is going to be equal to 0 at first, so 0 is going to be printed. Then it's going to increase by 1, and 1 is still less than 10, so it's going to print it, 2, 3, 4, until it gets to 10 here. And then if it's less than 10, so it's not going to print it. So we can expect this to print numbers 0 through 9. So if we run this, there we go. numbers 0 through 9. Hey Elemento, shit, did I miss much? No, we just started actually. We started talking about while loops and how to construct while loops. The topic for today will be loops in general, and it's on the website, whitehathacking.tech. The courses in, well, I can show you right now, right? There's only one course, so Python, Programming Fundamentals, Python Basics, and it's right here, loops. And then the other one is loops exercise. We're going to the last one later this week. Awesome, awesome. Yeah, the videos are going to be on YouTube as well, so it will help a bit. The text, I try to make this better in text because sometimes I don't explain it in the best possible way when I'm live. So, you know, uh, these videos are just more for a visual aid to the whole process. I got into school for a cybersecurity course finally. Awesome, dude. That's really, really cool. I hope you like it. In any case, let's continue. So, while loops are easy, right? This is literally all that they are. They start with while, they have a condition, any kind of condition. If the condition is met, it will keep executing the code, and then checking for the condition again, right? Over and over and over again until the condition is no longer true. So this is while loops. Now, for loops. For loops are quite different. So while loops are basically the bare loop, the most basic kind of loop. And it's useful, especially when you don't know how many times something will run for. Because let's say we have, I don't know, let's say we have, well, I can't think of an example right now at this particular point, but you can understand the concept. Let's say we don't really know, or it's not an easy solution to know exactly beforehand how many times something will need to loop for. You can just type a condition right here, and then change that variable as time goes by, and it will keep looping until that condition is no longer met. For loops are more efficient when it's possible to know how many times it's going to execute beforehand. And that's basically the big difference. You don't need to specify how many times this will run, but for loops you do. It will become clear once I get into it. So in a for loop, the usual construct is for any kind of variable, let's call it I, in something, do something, right? This is the code right here, do something, etc., right? Let's give an actual example. So let's declare a list, 1, 2, 3, 4. Let's delete while loops for now. So for I in A, let's call this my list. So for I in A, we're going to print I. Oops, print I. In my list, sorry. And print, there we go. So if we run this now, this is going to print 1, 2, 3, 4. So what is happening here? So first, the for loop, well, it starts with for, and then it takes a variable, any kind of variable. It creates it on the spot and uses it. You can put whatever variable name you want here. I is usually used, but you can put whatever variable name here. And then it's followed by in, and then an iterable, like a list. And an iterable is basically an object that you can iterate through. So a list, a tuple, a string, a dictionary. These are all iterables. And we'll look at what really makes an iterable when we go into object-oriented programming, and we can create our own iterable objects with classes and so on. But for now, just remember, like, iterables, lists, tuples, sets, dictionaries, strings. An integer is not an iterable. A float is not an iterable. Okay. So you have an iterable, and it's going to loop I and iterate it through all elements of that list. So the first time it executes, I is going to be the first element, 1, and then it's going to execute all this code. then it's going to become 2, the next element, and execute the code. Then it's going to become 3, then it's going to become 4, etc. Until there's until there's nothing else in the list. So that's why when we run this and we print I at each stage, it becomes 1, 2, 3, and 4. Now, of course, we can print I twice. We can do as many codes as we want, and you'll see 1, 1, 2, 2, 3, 3, 4, 4, right? Now, this is really helpful because you can now iterate through list elements and tuples and anything that is iterable, and that's pretty useful, as we'll see later when we make our own projects. You can also iterate through a range. For example, for I in range 10, print I. This is going to print numbers from 0 to 9. This range here is very helpful because what range does is range takes up to 3 arguments, okay? It takes a start, it takes, wow, okay, it's here, right? It takes a start, it takes a stop, and it takes a step, right? So, the start is the number you want to start it with. If you don't put anything, it will be 0, right? So let's say we want to start at 1. The stop is where you want it to stop, let's say 10. But remember, the stop is always non-inclusive. So if you want it to stop at 10, it will actually stop at 9, right? So if you want numbers 1 through 10, you have to put 1 through 11. And the step is how the variable will, how the numbers will be stepped into. Okay, for example, from 1 to 11, right? If we don't specify a step, the default is 1. So it is 1, then it's 1 plus 1, 2, then it's 3, 4, 5, until 10. Now, if you provide a step of 2, for example, instead of adding 1 all the time, it's going to add 2. So it starts with 1, then goes to 3, then 5, and 7, etc., until it reaches the target number. So let's say 2 here. Now this object right here is going to return, so let's say A equals this range object, let's print A. Let's ignore this for now. If we do this, there we go. It prints a range because this is a range object, right? If we print type A, it will give us class range. Now you can convert this into a list, and if we convert this into a list, it will tell us the list is 1, 3, 5, 7, 9, because these are the numbers 1 until 10 with a step of 2. So first is 1, then it's 3, then 5, then 7, then 9, and then it's not 11, because remember, this only goes until 10. So, okay. And what we can do is we can iterate through this range object, right? So if we do for I in A, print, for I in A, print I, this will print all the elements of that range. And this is really useful because we can do for I in range, actually, I already did it here. This is useful because we can do things like this, right? So we can execute code as many times as we want to in a range or in an iterable. That's basically what for loops are. And since you have to provide the iterable beforehand, and the iterable will have a specified length, you know already exactly how many times the loop will run for, at least in its maximum. And this is basically what I've been describing here. Yeah, we talked about ranges. Yeah, list sets, dictionaries, tuples, strings, frozen sets, everything. Except for like floats, integers, etc. The break is a really important part. Well, what is a break? Well, I was saying that we know exactly how many times this will execute at worst, which means it's going to execute the total length of our iterable. So if we have my list, a list of 5 elements, it's going to run 5 times, right? 1, 2, 3, 4, 5. However, if we wish to stop the execution before the end of the iterable, we can by using the statement break. As soon as this break is hit, the loop is exited. So as you can see here, the loop starts and then there's a break right after, which means that it's only going to execute once. So if we click play here, only the number 1 was output, right? Now, of course, you can add conditions. So if I equals to 3, for example, it's going to break. So now it's going to loop through the whole list, but if I equals 3, it will immediately break. So we can do this. Oops. What did I do wrong here? Did I do something wrong here? No, okay. So you see 1, 2, 3, and then it breaks, right? And this applies to all loops, both for loops and while loops. And that's really all there is to it. Let's take a look at one more thing, by the way. And this is something that I included it in the document today, but I don't think we talked about last week. In functions. So we know how to create functions. There are two things that I don't think I talked about before, which are type hinting and function arguments in more detail. So when you have a function, this function is called mul, and it's going to return, it's going to multiply a and b and return that value. So if we say print mul 2 and 5, it's going to multiply these and give me 10. Right? Perfect. Now, these are, I'm specifying these arguments positionally, right? And that means that I am, I intend for these arguments to be read in the same position that I'm specifying them, right? So if I specify 2 first, let's clean this up a little bit. Result equals this, and let's print result. So still the same result. When we take 2, it's going to, it's the first position. It's going to map this into the variable in the first position, in which case it's A. Then it takes 5, and it's going to put it in the same position, in which case it's B. Right? And this is specifying the arguments positionally. Thank you very much for the follow, Pasta. Appreciate it. And so this is specifying the arguments positionally, but you can also specify the arguments in another way, in a keyword argument way. So instead of saying 2 and 5, we can say a equals 2 and b equals 5. Right? And this will be exactly the same. Probably if we want to make this a bit more obvious, we can do a minus b. In this case, I'm going to replace this with sub instead of multiply, and sub. So if we do this, it's going to be -3 because 2 minus 5 is -3, right? And it's the exact same thing as providing it positionally like this. However, the difference between doing this positionally and doing this via keywords is that you don't have to specify them in order if you do them with keywords. So you can say b equals 2 and a equals 5. So we're specifying the b before the a, but this will still... Holy shit. This should not have happened. Wait. Oh, I'm an idiot, of course, because I'm specifying a is 5. What I meant to do... I'm an idiot. What I meant to do is specify a is 2 and b is 5. And this will still give me -3, right? Because we're doing 2 minus 5. And again, if I do the exact opposite, oops, we're now doing 5 minus 2, which is 3. And we can't do this in a positional way, right? Now, important to note, if you do things like this, you cannot, you have to specify the positional arguments that you want to specify positionally before you specify any arguments that are keywords. So for example, oh wow, thank you very much for the tip, Elemento. Damn, thank you very much. Oh, I even got a message for that. Really appreciate it. Okay, so peace. Oh god. So as I was saying before, if you say there's no sub button yet, that is very true. I hope there will be at some point. I have a lot of friends that want to sub with Prime. I hope there will be at some point. I think I need to clock like 50 hours or so. That 5-2 reaction was worth it. Well, I was not expecting it. Thank you very much. Really appreciate it. Okay, I'll talk to you guys in a bit more. I just want to get this point across because, well, I want people to not lose their train of thought here. So if you provide a keyword argument, so let's say b equals 5, and then you provide positional argument, the linter in Python will already tell you that this is a mistake. Positional argument cannot appear after named arguments. It's actually pylance now. But if you run this code, it will give you the error. Positional argument follows keyword argument. Bad. You can't do that. Even if you put a equals 5 and 2 in here, it's still the same thing. If you're specifying anything in a keyword way and anything in a positional way, you must specify the positional first and then the keyword after. Right? You can do this. And 4 minus 3 is 1. Now, this is weird, right? Because you can access variable, you can pass arguments as both positional or keyword, and it can get pretty confusing if you forgot exactly what the order of these variables are, and what really is the advantage of doing it one way or the other. Doing it positionally has a lot of advantages because if you have a lot of arguments, say you have A, B, C, D, E, F, right? We're not doing anything with them right now, but it doesn't matter. Let's say we have all these arguments. Well, let's say this was actually, let's call this first name, last name, age, job, let's say this, let's say, let's just say this, right? And then we're going to return first name. This is really stupid. We're only taking care of one of the variables, but of one of the arguments. But still, say it accepts all of these arguments. Now, if we were to provide them positionally, right? You just have to do John Smith. John Smith. 31 and electrician. Is this how you? I don't know how to type that. Let's say security analyst. I don't want to think too much about that. Okay, this is easy to understand. Now, if we were doing this in a keyword way, right? We'd have to do this. And yeah, when you click save, if you have the formatting set up, it will format it nicely in 2 lines. But you can see how this takes up a lot more space, a bit uglier or a bit less intuitive to read, especially if you have a lot more variables than this. And some functions, especially for bigger projects, do have a lot of different variables, many of them which are optional. And doing it like this is a huge pain. But it also might be really helpful to you, because doing this in a keyword way will not will always work if you change the position of the argument. So let's say you're only doing this in a positional way, right? And you change the function, and for some reason you changed it in an update, and you did this. Now, this thing will not work anymore as intended because this John is going to last name instead of first name, right? But this still works because first name is still first name and last name is still last name, right? So that's one of the advantages of keyword arguments versus positional arguments, is if you change the order in an update or something, it will not break all of your code. Or if you add another variable, right? So let's say you add, say you think, oh, I should also have hair color, and for some reason hair color comes right here. Well, now Smith is going to that hair color, 31 is going to here, security analyst is going into age, and let's say job had a default, so equals 0, right? So this whole thing would break. So that's why keyword arguments are also pretty helpful with that. Now, we talked about, let's go back into our the original code. We talked about default values a couple seconds ago. How do we provide a default value, right? Because maybe we want to subtract, be able to subtract two values, so A and B. So let's say we're subtracting 2 to 5, so this will be 3, makes sense. Now let's say that we want B to be always 1 by default, so that we don't have to specify it if we don't want to. So if we just put 5, A is going to be 5, but B is defaulted to 2 or to 1, and it's going to give us 4. Because if we run it right now, it's obviously not going to work because it expects 2 arguments. We're only giving them 1. So how do we make this a default? Well, you just have to put equals to something. So let's say equals to 1. In this way, if it's not specified, it will default to whatever's in here, and it will give us the result, in this case 4. We can put 2 in here, this will be 3. The same way we can do 2 in here, and now if we don't specify anything, this will be 0, because it will use these defaults, right? This is easy to understand. Now, I'm just mentioning this for completeness, and because when I was writing this earlier today, I decided to put it in because it just came up in my head. What if you want to make arguments keyword only or positional only, so that you can only call them in a positional way, or only call them in a keyword way, and not both? You can do that too. It's not that useful, but it can be useful in some scenarios. So now, let's say we have sum. It takes A, B, C, D, E, and F. Okay, and it's going to return the sum of all of these arguments, right? So now, sum, so let's say it's going to sum all of these arguments, and we're going to print a result. And if we run this, oops, oh, I'm an idiot. And if we run this, it's going to give us 21. Perfect. Oh, for some reason I'm not connected. Oh, there we go. See if I missed anything. I did not. Awesome. So all of these arguments are normal arguments. So we can say A equals 1, B equals 2, C equals 3, D equals 4, E equals 5, F equals 6. This is the exact same output, and we can do this. But let's say that we want A and B to only be accessible through positional arguments. And then C and D can be accessible either keyword or positional. And E and F are only keyword. How do we do this? It's actually really easy. There are two things we need to add. First is a forward slash. A forward slash, you can add it as another argument. Everything to the left of the forward slash cannot be accessed via a keyword. Right? To the left cannot be accessed as a keyword. So A and B cannot be accessed as a keyword. And if it can't be accessed as a keyword, it has to be positional. Now C and D are just normal again. And then we can add an asterisk. Now anything after the asterisk cannot be accessed positionally. So E and F cannot be accessed positionally. So E and F have to be accessed via a keyword. So if we run this right now, we'll have an error. For some reason. Oh, I'm an idiot. I forgot to change these. Okay. So 1, 2. Okay, let's do this. There we go. Now it gives us 21. Again, 1 and 2 are the positional arguments, A and B. If we try to say B equals 2, boom, this will give us an error. Got some positional only arguments passed as keywords, B. Positional only arguments. So this has to be positional. Now, what if we do 3 instead of C? This works, because C and D are either positional or keyword. Because, remember, the asterisk affects everything to the right. This affects everything to the left in this way. So C and D are not affected. Then E and F, if we try to, so let's say we have here, so this still works because these are positional. And I wanted to put 4, which is why it gave me 22. Okay. Now, if we don't put an E here, we'll give another error. It takes 4 positional arguments, but 5 positional arguments and 1 keyword only were given. Right? And that's it. And why is this helpful? Well, it can be helpful if, for example, let's give let's give an example that might actually be helpful. Let's say I don't know. This is hard to think about right now for something that would make sense. But let's say add book, and we have say we have book name, and we have and this is position, and this is and these are keyword only. Book name and book date, whatever, I don't know. And we're going to return book name and book date. Okay. Let's just do result, add book, book date equals 2020, book name equals awesome book. Right. Now, if we print this result, pretty basic. Just give them it's just going to return a little tuple with awesome book in 2020. Right. Okay. Now, let's say you didn't have this keyword only argument. Keyword only arguments. Let's say that these were any kind of arguments. So in this case, you could do this, or you could just specify this. Let's comment this out. We can just specify this as a value instead of value attached to a keyword, right? Just as positional arguments. Now this works well. But let's say later you might change some aspects of this function, right? So you might also include a book author, which doesn't need to be filled. So it's going to have a default of this. Doesn't matter. Well, we have to add a default for this too. Let's actually have this. You know what? Let's actually have a default for all of these, because we don't need these to be filled. Right? Now, if we do the same thing, this will completely break the code, because well, it's taking the first positional argument into the first one, which is book name, perfect. Then it's taking the year, but it's going into book author instead of book date. Right? And now it's going to return the book name and book date, and book date is empty. It's its default value. Right? Problem. Now, if we did this, however, still great. And of course, this is only a problem if the people are using your code incorrectly. But this will happen if you have a project and people build scripts for that project, and you updated a function to be something like this, then every single script that everyone has made using positional arguments is going to be wrong, is going to give you the wrong result. To avoid that, you can make these keyword only. And this way, there will be an error to it. So people will know that it's wrong. Right? And people will have to use keywords from the start. Because if you don't do this, I'm pretty sure people will use positional arguments in the function call. And or they might. So if you want to restrict that from being a possibility so that your code is easily maintainable, errors don't happen as often, scripts are not breaking as often, you can do this. Of course, there are many more applications of this and you might find your own, but just a little example of why this might be useful. Now, when you are defining functions, another thing I wanted to point out is type hinting. I also talked about in the function lesson here. And type hinting is something that helps you and other programmers when they look at the code, and also static analyzing, static analysis programs, and even when you're doing some static analysis, it will help you figure out what's happening with the code. So let's say we have a sum. We take x and y, we return x plus y. Oops. Damn it. We return x plus y. This is perfect, right? We know that the result equals sum, let's say 2 and 5, and, oops, I'm an idiot. Now we're going to print the result, right? Perfect. Now, it's 7. 5 plus 2 equals 7. I don't know why 5 and 2 are numbers that I really like right now. Now, if we add some type hinting into this, it will look like this. Or it could look like this. Type hinting, so what is type hinting? Type hinting is making use of these colons, this construct, to hint at the type that the variable is supposed to be. Now, it's important to note the interpreter does not care about any type hint, right? You can pass strings into here, there will be no errors. Type hints are just for you to look at your code and say, okay, this is supposed to be an integer, this is supposed to be an integer too, and this little arrow sign tells you what the function is supposed to return, which will return an integer, okay? And this is going to help you look at the code and instantly see what it's supposed to be receiving and outputting. In case you have like a lot of functions, big project, a lot of things can be returned, or I'm sorry, there's a lot of things going on inside of the code, and you can't immediately tell what the type of the variables that are being returned are, all of that. And you want to make docstrings a bit more specific to telling you what the function does instead of telling you what the types are. This is an easier way to specify or to hint at what's supposed to happen in the function. This also helps static analysis programs go through the code and figure out if there are any problems with it. Now, this is not limited to function definitions. You can also say a string equals hello, right? And this runs normally, as if this type hint was not here. The type hint is only for you. It's not really very useful to do things like this because it will just add more bloat into the code, and anyone can see that this will be an integer without you having to hint to its type, but you can do it. So yeah, that's all I wanted to talk about. And now into the exercises. Now, if you don't want to look at the exercises, well, you know what? I'm just going to do the exercise for last week's, not for today, because I'll do it next week. Anyway, so this is the exercise for last week, which is to create a function called checkParity that accepts one argument and checks if that argument is even or odd. If it's even, it should return true. If it's odd, it should return false. So let's go into here, parity py. Well, I should probably type it correctly. Okay. So, no, I don't want a docstring. Okay. So, this is the task. It's easy. So we're going to create a function called check parity. It accepts one argument, okay, and checks if it's even or odd. So this tells me this is a number, right? I'm going to put n because n for number looks better. Now it checks if it's even or odd. So how do we check if it's even or odd? Well, there are many ways to check this. If you recall the last exercise about being even or odd, we can do this with the modulus operator. So if n modulus 2 is equal to 0, this means that it is even. So you can return true because it's even, and even should return true. And else you should return false. Now, if we want to make this code a little bit smaller, well, we can make this into a one-liner, right? But smaller within reason of readability. We don't actually need this else here because because we know that return will immediately exit the function, right? So if this is true, the function will be exited, so this won't run. So this here will not run. And if it's not true, this will run. So we don't need the else. Also, we don't need this equals 0, because we know that when we evaluate expressions, 0 automatically goes into false, and anything else is true. So if we don't put this 0 here, and if this is 0, it's going to be false. So if this is a 0, it means that the number is even, right? But if 0 becomes false, this condition will not become true. So we should return false here because it will be odd, right? So if n modulus 2, meaning if this is true, which means if this is not 0, we return false, else return true. Or we could just do this, return a true, return false here. Okay, easy. This is the easy way to do this. We can copy this, paste it here, and see if it's correct. And there we go. Seems to be correct. Now, it seems to be correct because there was no error message when you click check answer. That's what would happen. So if I put true here, for example, and it's wrong, right? We click check answer, it will give us that it failed the hidden case test, right? So there you go. Okay. What are other ways to do this, by the way? And we can check if it's correct as well, because we can just fine. Check parity, let's say, of 2. Fine, 3. And if we print the result, it will give us false because it's not even. But if we put 2 and we print it, it's going to give us true because it's even, right? Now, what other ways could we do this in? And I promised that I would do this in other ways as well, so that we can see that there are many different ways to solve a problem. Now, if we do this without the modulo operator, it's also possible. It's also possible, and this is one of the ways how. So we need it to return true if it is even, right? So let's initialize a variable, which will be a boolean, equal to true. Now let's loop. Remember, we just learned loops. Loop through the whole variable n, so 0 through n. and we're going to return, and we're going to say result equals not result. And now we're going to return result. Now if we do this right now, this will give us true. If we put an odd number here, it will give us false. This works. Why? And by the way, this underscore here, I didn't talk about it in the loops, but underscore is just it's a valid variable name, just like I or B or C. But out of convention, this is just because, you know, it's the convention people usually use. When we put an underscore, it means we don't use the variable. We don't care about what this variable is. Right? It's still just a normal variable. You can use it. You can print this variable and it will print 0, 1, 2 because it's looping through the range. But by putting it as an underscore, I'm just telling the next programmer that looks at this that I don't care about that variable. I don't use it. That's all there is to it. Now, what is this really doing? Well, first I initialize a variable called result into true. Let's track this variable. First it's true, right? Then I'm going to loop through the number that I give. So let's say the number is 2, right? Let's say the number is 4 actually. We're going to loop so from 0 to 3, so four times in total, 0, 1, 2, 3, 4. 0, 1, 2, 3, so four times in total. And we're going to change result to be the opposite of itself. So first, result will be false. And we'll start with 0. Then, result will be true again. We start with 1. Then, result will be false again, 2. And then finally, the result will be true again, 3. Now, if instead we start with number 5, or let's say the number 3, first it would be true, because it starts as true. When the loop starts, it becomes false. And then it becomes true again, and finally it becomes false. 0, 1, 2, 1, 2, 3. Hey Marin the Wolf, how are you doing? And so, as you can see, the result is becoming the opposite of itself an even number of times if the number is even. And it's becoming the opposite of itself an odd number of times if it's odd, right? So what this does is, of course, if you make something the opposite of itself an even number of times, it will always be the same as the beginning, right? Because if it's true, and you make it false and true twice, it's then false and it's true again, right? And if you make it 4 times, it's false, true, false, true. So if you do it an even number of times, it always is the same as the beginning. If you do it an odd number of times, it's the opposite. So that's how this works. This particular function works. To check the parity of a number. And we can put this here too. And we'll see that this does not fail the test, so it works. Thank you for the follow, man. Really appreciate it. So yeah, so that's all I wanted to talk about. And this exercise done. Now the next exercise. Okay. So the next exercise. Let's click next here. Oops, I need to finish the exercises. Next. The next exercise is today's exercise, right? So we completed the loops for today. Now if we go into next here, we'll have the list add print. This is the exercise for today that I'm leaving you guys with, which is to create a function called add print that accepts one argument, which is a list of numbers. This function should return the sum of all the values in the list plus 1 for each number. Give an example. So if we have a list 1, 2, 3, and 4 in the list, it should return the number 14. So 1 plus 1 plus 2 plus 1 plus 3 plus 1 plus 4 plus 1, right? Which equals 14. There's a solution here if you want to check it out, but I suggest you try it on yourself. It's just a little exercise. And yeah, and that's it. Are there any questions here? Do you guys have any questions? I'm prepared to answer any question at this particular moment. I think I went through basically all the material. Yeah. I will end this stream in 10 or so minutes if there are no specific questions. At the moment, it's pretty clear. Awesome. I'm glad. Um, yeah, there are some particularities that I didn't mention. But so, for example, we're dealing with lists in this exercise right now, and we talked about lists as a data type before, but we didn't really get into how to add items to a list, how to remove items of a list, how to access lists, and so on. Um, and the same thing for tuples, dictionaries, so and sets. So we did skip over some of these things, but we're going to talk about it when we actually use them in practice, because it's a lot better to understand it when we use them rather than just theorizing about them. And we're going to use them pretty soon. Um, the next lesson, so right now we did loops. The next lesson is probably going to be a breakpoint, because we, so if we look at all of the basics we covered data types, operators, conditionals, variables, and input. We did have some exercises in the way, functions and loops, but I think it's time for uh, a big breakpoint where we make a quiz with every single thing that we did so far, and start making a little project with it, just a tiny project with it. And it's in this project that we're going to include a lot of these other things like dictionaries and lists and a lot of how to manipulate them. I'm not entirely sure what the project will be quite yet, but it would be awesome if you guys could tell me some ideas you might have. Yeah, I'll deal with this in a bit. Also, don't forget, there is a Discord server. You can access it if you go into the website and here into community. If you click it, you'll go into the Discord server. It's called Whitehat Hacking, and it's what we do basically. And you'll find a lot of people to talk to about, obviously, hacking. And yeah, I gotta add the merch again. Oh, damn it. Oh well. No idea why it's not here. Yeah, it seems there are no more questions at this particular point. That's great. Okay. Also, by the way, for people who might watch this later, or who might want to give a suggestion later, you can always message me on Discord or message any of the moderators or admins and tell them a suggestion that you'd like to include for one of the projects, either now or in the future, for this particular course on programming fundamentals, and I'd be more than happy to receive that suggestion and pledge. Also, um, if you go into the welcome channel of, into the announcements channel of the Discord server, there is a poll unit right now. There's a poll going on, which you can click and go to. And this poll is basically for perks that will be added into our own server. So we're basically thinking about adding a leveling system. So the more you chat, the bigger your level will be. And we don't know yet what kind of perks. We have some ideas, but we'd like your input on what kind of perks you would see, you'd like to see us include for these chatting levels. So you can just drop your idea here, completely anonymous, or not if you wish. Actually, I think there's no option. It has to be anonymous. So, except for commenting, but yeah, you can just add your idea, and you can heart some ideas as well. Get perk for lurkers like me. Well, there might be some interesting things for lurkers too. We don't know yet, but there we go. You can always add an idea here. You're welcome to. But yeah, but that's it. Okay. Also, let me look into the dashboard. Okie dokie. Okay. 1 hour, 22 minutes. That's not too bad. I think I will end it for today here. Thank you very much for coming by. Thank you for the $5, man. I really appreciate it, and it will be really useful um, for this Christmas too. um, Thanks for the awesome stream. No problem, man. Anytime. Well, I'll try to do these every week. At some point, I might be able to do these more frequently, but for now, I think every week is the best. Is the best for me at the moment. But I'll definitely try to make the stream more awesome each time. Thank you for coming by, and if we don't see each other again, which we should, but if we don't, have a Merry Christmas. Yeah, I'm not ending it yet because of the delay and all. I want to make sure that everything. I want to get this to the end and succeed. Me too. Me too. I wish you the best of luck. Yeah, I think it might actually help you a lot with cybersecurity course because you'll be doing a lot of programming. You might do Python as well, and it's always good to um, do some practice with it. Also, there's the advent of code going on right now. Now, of course, this is not really. A lot of these are for um, people to practice their code with. You can sign in with GitHub. Basically, every day there's a different challenge. You can do these in any programming language, of course. It's just a little programming challenge. Some of them are really easy. Some of them are really difficult. Um, at this moment, there are not really any difficult ones, um, but yeah, on my GitHub, I have a repo for the advent of code solutions. Maybe I'll ask questions down on Discord, as also I get 1 year free support from a guy at school. It's Homestead. It's okay, awesome. That's really cool. Yeah, definitely come ask questions in the Discord server. We'll be more than happy to help you out. And yeah, in my GitHub, you'll also see some solutions that I posted. Not for all days because I lost a couple of them, but they should be commented and all. If you're into that. But yeah, definitely come by. Anyway, I will have to go now. I wish you a Merry Christmas and have a nice day.